Hello and welcome to this Liberty Basic lesson on functions. This may occur in Computer Science 30S or 40S depending on the course year and the student. All right, so let's look at functions. By now you should have looked at reporter blocks in BYOB or SNAP or whatever it happens to be called after you've taken the course. The reporter blocks in SNAP take values and do something to them and then return a value. And you may remember this where we did a max of an X and a Y and we reported something back. This is known as a reporter block in that particular programming environment, but generically in computer science, this is referred to as a function. So after this lesson, you'll be able to write a function in Liberty Basic and understand what a function actually is. Liberty Basic has many built-in functions. For example, left string, len, cosine, pretty much every command that you can think of is basically a built-in function that someone's written in another language and converted to Liberty Basic. And Liberty Basic allows you to create your own as well. So for example, we're going to count the words. We're going to input type of sentence string, and then we're going to print there are word count sentence strings words in the sentence. This particular line right here calls the function word count that you've defined yourself as a user, as a programmer, and sends it the variable sentence string. So word count is the function, and the brackets here indicate that the variable sentence string is being sent to the function word count. Here is the actual function word count. You define it as function word count a string. Notice that these are different names here. It's generically called a string here because remember, you want to be able to use functions in many different situations and you don't want to have to ensure that the variable names match up. So we use a generic a string here. This, of course, is the function definition and it must come after the end statement in the main program. So we set my index equal to 1. By the way, this variable here is scoped locally. The main line is not aware of the function or the variable index. So while word string sub a string comma index is not equal to the null string, index equals index plus 1. This is my count right here. So I'm going to keep looping. I'm going to keep looping here until I get to the end of my sentence. Word string is a predefined Liberty Basic command that skips from word to word. So basically this loop here counts the words. When I'm all done, I have to set my word count equal to index minus 1 because it's going to count the null string at the end. So it loops through the variable a string, which is of course, as I said, a local variable, and counts the words in the string. Notice that the name of the function word count is used in the last line of the code to return the value to the main code. So just like in a reporter block back here, where you have to report something, you must report back in your function, and to do that, the last line in the function must be the name of the function and what you want it equal to. So I've got word count equals index minus 1. It's going to send the value of index minus 1 back to the mainline code as this value right here. So what it does is it allows you to use your mainline code becomes much more efficient, much more compact. You don't need, could you have put all of this inside your mainline code? Absolutely. But the function allows it to sort of be separate. It separates the tasks, makes for easier group programming. So let's talk about some advantages to functions. You've probably seen some of these already before. It allows the programmer to reuse a bit of code in various places. They can create a library of their own functions. Functions can be called from different parts of main code. You don't have to copy and paste all the time. It cleans up the code, easier to read and program. It allows one person to write the main code and another one to write functions. So the general format of a function is you define it as function and then function name, argument 1, argument 2, and so on, as many arguments as you want. You put some code in here. This is the code that does the function, and then you have function name equals some value at the end. Notice the indentation. Everything inside the function should be indented, just like it would be in a loop or an if. The variables in the brackets are called parameters or arguments, and the last line of the definition must be function name equals some value. Arguments themselves could be numerical or string. They may not be arrays. Arrays are globally scoped that you cannot pass an array. It just functions automatically are aware of arrays. Once the value is passed, it may be renamed. The variables inside the function cannot see anything but the arguments that were passed. And remember, this refers to the variable scope. Once the function is ended, the function's variables have no value. So, for example, index in the previous one doesn't exist when you get back to the mainline code. And remember, this is called passing by value. Copy of the argument is passed, but not the original variable. So just a bit of a review. Remember, passing by reference. If you want the program to send a variable that can be changed, it has to be passed by reference. In other words, its name, not just its value. Simply include the command byref in the function name. So for example, function word count byref a string. A string can now be added in the function. So it's not just a copy of the variable or a copy of the value, but it's the actual variable itself. So I'd like you to try adding these changes in blue to the example code. If you haven't typed in the example code, you should go back and do that. Pause the video if need be, and then I'd like you to add these small changes here, and then we'll talk about it. All right, so hopefully you've had a chance to type those in. You've got input type of sentence. There are word count sentences, and then after I added in blue here, print sentence string equals sentence string, print a string equals a string. And when you run it, what you should find is that those values do not get passed through. I'm going to copy and paste here to a Liberty Basic file and just show you what it should look like. And let's run this. Type a sentence. The dog is brown. There are 4 words in the sentence. Sentence string is equal to the dog is brown, but a string does not exist. Okay, once I go to the function a string here, once I got a string equals done, it goes back to not being anything at all. A string is completely wiped out. The mainline code here, a string, is not aware of the function a string at all. Now I'd like you to try adding byref to the function definition, like so. Okay, so change that byref. Sorry, it doesn't go in there. Put it in the wrong spot. It doesn't go in there. It goes in the function definition, like so. Now let's see what happens. Sentence string becomes done. Okay, it isn't aware of a string, but what it does is that a string becomes done, and that is equal to a string is the same thing, is equivalent to sentence string. So when I print sentence string right here, it's equivalent to the a string that's equal to done. So that's useful in some situations. You have to know sort of when to use it. A reminder to place all functions after the end of the main program. This ensures that the regular program flow does not run into functions. Make sure you have an end in your main program. Make sure you save before you run. You don't want a Stack Overflow. Here's practice assignment number 1. Write a short piece of code that takes a numerical value and rounds it. So for example, 3.2, and it rounds it to 3. So I'd like you to create a function called round that will round it properly. And if you want to try that on your own, you can start now. If you want a little hint, then let the video keep playing and I'll give you a hint. Here's the hint, some pseudocode for you. You should get the number, decimal value, call the round function, print the rounded value. And the round function looks like this. You add 0.5 to the value to round and take the int of this, call this top, take the int of the original value and call this bottom. So for example, if you're rounding the number, let's go with 3.2, okay? So you would add 0.5 to this value, so you'd get 3.7. Take the int of this and call this top. If you take the int of this, you're going to get the integer portion is 3. Take the int of the original value, so the int of 3.2, gives you 3. If bottom is equal to top, then the original number was to be rounded down, and the rounded value is top and bottom. If top is bigger than bottom, hold on here, let me just see my logic. All right, so I am good. I had to make sure that I was correct here. If the bottom is equal to the top, the original number was to be rounded. This should read down, rounded down. So because this 3 is equal to this 3, then my original value must have been less than 3.5, right? Adding 0.5 to it kept it as a 3 point something. So that means that my 3.2 should be rounded down, and the rounded value is both values of top and bottom, 3 and 3. If top is bigger than bottom, let me give you an example of that. Say I've got 4.7. I'm rounding that. I add 0.5 to that and I get 5.2. When I take the int of that, I get 5. If I take the int of 4.7, I get 4. They are not the same. Top is bigger than bottom, so the original value should be rounded up, and so the rounded value is top. 4.7 rounds up to 5, and then you should return the correct value. All right, so go ahead and try that. I will show you a solution after. Pause the video now. All right, hopefully you've tried that. You may have realized that the handout that you probably have in front of you actually has the solution here. So here it is right here. Not particularly hard. Let's just copy that to a Liberty Basic environment. And let's see how it works. 3.2 rounds to 3. 3.7 rounds up to 4. Okay, so how did I do that? I input the number to be rounded, call the number. Rounded number is equal to round. Here's my function that I'm defining as round. I'm setting it the value of number, and I'm printing that rounds to. So this is my mainline code. The function code here looks like this. Function round sub x, bottom equals int of x, top equals int of x plus 0.5. And I combined those two steps right here, right? So I said bottom is equal to the integer version of the original x, top is equal to the integer version of x plus 0.5. If top is bigger than bottom, then the round is equal to the top. Otherwise, round is equal to bottom. And let that run. Okay, so a hand-in assignment here. I'd like you to write a piece of code that takes an x and y coordinate, rounds them to the nearest integer, then displays them in brackets with a comma in between. So for example, enter an x coordinate 3.4, enter a y coordinate 4.8. The whole point that is closest to that is 3, 5 with brackets here. So it takes the 3.4, rounds it to 3, takes the 4.8, rounds it to 5. Use a string function called round and format string. You can also have string functions. They don't just have to be numerical. To return the string bracket 3, 5 bracket. You may call your round function that we just created inside your round and format function definition. So it's sort of like a composition of functions that you probably learned in a previous lesson way back in SNAP or BYOB. You should use the built-in function str string at some point to convert a numeric into a string value. So you need to convert the numeric value 3 into the string value 3. This might be a bit of a challenging little assignment. I'll be happy to help you. Here's a bit of a hint if you need it. So here's the main code. Input, enter an x coordinate x. Input, enter a y coordinate y. Rounded string is equal to round and format string x, y. Print that rounds to. Here's the function called round and format. You need to write this code. And here's the function round that you previously wrote. So you can go ahead and just cut and paste that in there. All right, that's the end of the lesson on functions. Good luck with that. I'll be happy to help you with that particular assignment.